Hey guys, this video is going to go through the TestNav practice questions for the SOL. These are not all 28 of the questions, just the ones that I feel like you should either know how to do or could at least take a good guess at. Also ones that you would know how to do if you're in class this week and you are able to learn a little bit about quadratics and inequalities. So let's get started here. Question number 1, what is the value of this expression when A equals 8, B equals 16, and C equals -4? So this is a pretty straightforward substitution problem, which means they want you to take 8 and put it right here where A is, 16, put it here where B is, and -4 where C is. So as always, we're going to copy what we see and we're going to substitute. Now notice that this square root sign has a 3 on the top. That's called a cube root. And if you've never worked with those before, that's okay, because remember, our secret weapon is Desmos. Now be careful when you're substituting for C, because there's a negative in the front, but C is also a negative number. So you got to have both of those signs. 16 would go here. All right. So in Desmos, you guys already know how to type a square root. I'm going to show you how to type in a cube root. So let's go there. I'll take it out and start it over again here. So the first thing is 5, and then we have that cube root. So this right here symbol, this is the square root symbol. See, there's nothing above it, but we don't want that. We want the cube root. So here's what you do. You go to where it says functions, and you look under miscellaneous. There's several different things here. A bunch of this stuff you have absolutely no need for. But if you look under miscellaneous, you'll see a square root that has an n. And what that means is that you can type this, you can click this, and then you can put the 3 up in the corner. And it will tell Desmos to do a cube root. Then you're just going to type the rest of it, and you're going to make sure that it looks exactly like what you had, or what we had rather, written down. There's the square root. And when you type it in exactly, you'll see that Desmos gives us the answer of 35. So we can go back to our page and we are going to pick B, 35. Question number 2, which represents this expression in simplest form? One thing we did not get to do was talk about operations with exponents. There are rules about how to do a power to another power, how to divide powers, how to add and subtract powers. And we did not have a chance to do that. So in a problem like this, you're going to have to guess. But you can at least narrow down your answer choices. You know that 15 divided by 3 is 5. So you're going to want to look at the 2 answer choices that have 5 in the answer. That means we know it can't be A and we know it can't be B, so at least you give yourself a 50-50 chance here, okay? So whenever you see something like this, you know that the fraction bar is division. Forget about the exponents and the variables. Focus on the numerical part, and you can at least narrow down your answer choices. Question number 3 is another one that you can at least narrow down your choices. What is the quotient? And quotient, remember, quotient means division. So what is the quotient of, and it might help if you write this out, 15x squared minus 8x minus 12 and 3x plus 2. So they want us to divide this term by this term. And if we had been able to get to the polynomial unit and factoring, we would have been able to show you exactly how to do this question. We didn't get to that, but there's a little cheat here that you can use. Look at forget about the variables and look at the 2 constants. -12 divided by 2 is -6. And look for the answer that has that. Now, if 2 answers have that, then again, you're going to have to take a guess, but at least you'll be able to narrow it down a little bit. This is question number 6. The other questions are things that we just haven't had a chance to do yet. If I skip, whatever questions I skip through this whole video, by the way, are things that we haven't had a chance to get to and would be too complicated for me to show it to you quickly, so you're just going to take your best guess and move on, okay? What is the cubed root? Remember, when there's a 3 up here, we call it the cubed root. What is the cubed root of 3,456 in simplest form? If you go to the SOL review info page on Canvas, and you look for the document called Simplifying Radicals, you will see that I show you basically how to take these answer choices and turn them back into this. These are simplified radicals. This is an unsimplified radical. I'm going to go ahead. I'll do these here. If you saw this document, this will make sense. If not, maybe you want to go back to this. But basically, you take the outside number, and since this is a cube root, you put it underneath the radical 3 times, like this. This one would be you keep the 16 and then put the 6 in 3 times. This one would be you keep the 2 and you put the 12 in 3 times. And then this one, you, what's the word? Keep the 6, there you go, and put the 24 in 3 times because it's a cube root. Then all you do is multiply all the stuff underneath and see which one gives you 3,456. So 12 times 2 times 2 times 2 is 96. So that's not it. 16 times 6 times 6 times 6 is 3,456. So it looks like this is the right answer. But I'm going to go ahead and do all the answers. Like, what if I hit a button wrong and I don't realize it? I like to do them all times 12 times 12 just to make sure. Ooh, see, I just got the same answer. So something is not right here. Well, actually, that's not true. Hold on a second. And then we're going to do 6 times 24 times 24. Whoops, 6 times, my calculator doesn't want me to push all the buttons here. Okay, this one is 82,944. So it's definitely not this one, and it's definitely not this one. So let's look. We got the same answer on these two. Let's look closely here. A cubed root is something that could be multiplied out 3 times. If I have the square root of 16, 16 is 4 times 4, and 4 times 4 is 2 times 2 times 2 times 2. Since this is a cube root, if I take 3 of these out and leave 1 underneath, if I take that 2 in the front, then that would give me not 6, but that would give me 12. That would give me this one. So this is the correct answer. If what I just said here makes no sense, again, you can at least narrow down your answer choices to 2 instead of 4, and you have a pretty good shot of picking the right one. Okay, you want to look for a prime number underneath the radical sign. This 16 is not a prime number because it can be divided by a whole bunch of other stuff. So that is another thing that will help you to answer this one. But at least, like I said, if this part didn't make sense and you got these two, you could take your best shot and have a 50-50 shot. For question number 7, which value of x does 3 square root of x simplify to 5 cube root of 7? So they're basically asking us which one of these, if I put it underneath the radical sign, which one of these would equal this? Well, I have 4 different answers here, so I'm pretty sure if I just unsimplify this radical, I'll be okay. So I'm going to keep the 7, and I'm going to put the 5 inside 3 times because this is a cube root. And then I'm just going to multiply and see what I get. So 7 times 5 times 5 times 5 is 875, which means C is the right answer. Again, if this makes no sense to you whatsoever, you need to go to the SOL info page and you need to look at the document called Simplifying Radicals. I explain it all step by step, okay? Here is question number 8. Drag the answers to the correct boxes. Each answer may be used more than one time. Complete this equation to create a true statement. We're multiplying square roots here, and actually probably the thing that you think that you don't really know how to do this, but there's one thing you could try, is actually the right thing. Multiply the numbers in front of the radical. 4 times 2 is 8, so 8 would go here. And then multiply the numbers inside the radical. 2 times 3 is 6, so 6 would go here. 8 square root of 6 is the correct answer. Now for number 9, this is something that we have covered this year. So now we're back into familiar territory. Michelle correctly solved a linear equation, and the last line of her work was 1 equals 2. Which statement best describes the solution to the equations? You may remember, if you go back to Unit 2, Notes and Videos, when we talked about number of solutions, if you get a, x equals a number, remember that means one solution. If you get a number equals a different number, that means no solutions. And if you get a number equals the same number, remember that's infinite solutions. So this is just something that you had to memorize. And 1 equals 2 would fall in this category, that there are no solutions. So the only solution is 1, the only solution is 2, the solutions are both 1 and 2, infinitely no solutions. This is the one we would pick. There are no solutions. Oops. Somehow I got myself off of the pen. There we go. All right. So this is something that you just need to memorize, the 3 different solution types. And that's something that you could do pretty easily between now and your SOL. Question number 10, what are the solutions to the equation 2x squared plus 5x plus 3 equals 0? Okay, so when you have an x squared in the front, this is called a quadratic equation. And if you look on the SOL review info page, there is a document called Quadratic Equations. Whoops, quadratic, that E shouldn't be there. That gives you the most basic information about these type of equations. We've never seen equations with x squared yet this year. We didn't have time to get to that. Miss Oliver and I are going to teach you a little bit about that in class, but also there's the document to look at. Basically, this type of equation, if you put it on the graph, makes a shape called a parabola, which could look like this or could look like this. And when they talk about solutions, they mean where does the parabola cross the x-axis? And there might be one place, 2 places, or no places. So in order to find out which 2 numbers are the place where the quadratic crosses, the easy thing to do is just go to Desmos and type this in and let Desmos show you. So I'm going to pull up Desmos. I'm going to remove my other question here. And we're going to put in 2x. You're going to hit the a squared button to make x squared plus 5x plus 3 equals 0. And when you do that, let's zoom way in. What you can do is you see here's the x-axis, right? Let me put this, I just wanted to see something. Let me put the zero back in. Yeah, it's the same thing. You can have the 0 in or out, but here's the x-axis and you see the 2 gray dots. Look at the x number, -1 and -1.5. So I'm going to come back over here, and those x numbers, I'm going to write them down, were -1 and -1.5. So this one has -1 and this one has -1, so that can't be it and that can't be it. So you have to ask yourself, is this fraction equal to -1.5? I know it's not 6, right? So I want to guarantee -3/2. Let me go to Desmos and type in -3/2. Sure enough, that's -1.5. So that is the one that I want. Here is the one that is the answer, okay? Just graph it. When they talk about solutions, they're talking about where your parabola crosses the x-axis. Here's number 11. Type an inequality statement in the box. Use the less than or greater than for the inequality symbol. So they're telling you that you're not going to use less than or equal to, and you're not going to use greater than or equal to. So that's nice to know that you don't have to worry about that. Solve for x. There's two ways to do this. If you remember from, gosh, 8th grade, how to solve inequalities, you can do this. Oh, we're going way back in the way back. We're going to combine like terms. This is negative 7x minus 11. We have an extra variable. We'll get rid of the smaller one. Think way back to like October is when we did this. And then we're going to get rid of our constants. And we have negative 18. And we're going to divide by 2. And we get negative 9 is less than x. If you want to turn it around, you would flip it like this. X is greater than negative 9. Okay. If you remember how to solve inequalities, you can do this the same way. You will have to remember that at the end, if you multiply or divide by a negative, you have to flip the sign around, and that's something that people usually forget. So here's another way that you can do this one. Let me erase all this. We could go to Desmos and we could type this in. So let me show you what happens when we do that. Let me get rid of all that. Okay, if we type in this inequality, it is 6x minus 11 minus 13x is less than 7 minus 5x. All right, and you're going to notice that the screen is shaded in a particular area. You want to find the dot where the line is where it's not shaded and look and see what the x number is. The x number is negative 9. Now, you got to ask yourself, where's the shaded part? Is it greater or is it less? If the shader part is graded, or I'm sorry, the shaded part is greater, then you're going to use the greater symbol. So x can be anything that's in the shaded part. So x is anything that's greater than negative 9. And that is what we have here. By the way, for inequalities, you notice that when we type this in here, you see how the line is dotted instead of solid. So we're going to talk about this in class also. But if you have a greater than or less than, you're going to get a dotted line. If you have less than or equal to, greater than or equal to, you're going to have a solid line. We'll see that later on. But that's two ways that you can solve this problem. For number 12, we can do the exact same thing, all right? It says select array, drag the endpoint to the correct location on the number line, graph the solution set to this inequality. So they're going to want you to choose one of these and put it up here on the number line. So again, you could solve this yourself, or you could avoid errors and just type this into Desmos. So let's do that. You know that it's easy to make an error when you have to solve the equation yourself. So let's type it in. Negative x plus 4 minus 2 is greater than 2x plus 6. All right, so we find the spot where the split is, and we see that the x is negative 4. So we're going to want to remember that. And we also see that we have a dotted line here. So the dotted line means less or greater. So we're not going to use the less than or equal to, the greater than or equal to. It's either going to be greater than or less than. And we see that the shaded area is to the left, which is less. So we wanted to say that x is less than negative 4. Remember, x can be anything that's in the shaded area. So x is less than negative 4. So for less than, you need the open circle on negative 4, and less than would be going to the left. So you would choose this symbol, you would drag it up here and put it so that the circle's on the negative 4. Okay? So it's really nice that Desmos will show you exactly what it should look like. Let's stop here. All right, now for question number 13, it says, Frank works at a convenience store. He earns $7.50 when he works during the day. He earns $12.50 when he works at night, and he wants to earn at least $300 per week. Which graph best represents the situation? So we're going to take these two things and we're going to take these three things and turn them into an equation. Now, one thing you want to notice about your graphs is that the daytime is on the x-axis and the nighttime is on the y-axis. And that's the same thing for all these graphs. So remember when we talked about turning words into equations, we said that per was multiplying, and usually the variable comes after the per. So 750 per hour during the day would be 7.50x because daytime is on the x-axis. 1250 per hour would be 12.50 y because y is on the y-axis. And if we add those two things together, he wants to earn at least $300 per week. So he would like more, greater than, but he would be okay with exactly 300. So 300 or more would be greater than or equal to, and we're going to put that here. So this is his daytime hours plus his nighttime hours should be, should be greater than or equal to the amount of money that he wants. So what we're going to do is once we have this, we're going to just type it into Desmos and see which one of these four graphs match. So I have that typed here. And all we have to do is look at what these points are. So this is going to be 40 on the x-axis, and it's going to be 24 on the y-axis, 40 and 24. So let's look. We need 40 and we need 24. So I've got 40 here, and it looks like this could be 24. Let's check the other ones. This one is not 40. This one is 40, and it's 24, but look at the shading. This one is shaded above, this one is shaded below. Which one does our graph look like? Shaded above, okay? So we know it's not going to be this one. And then we have this one doesn't end at 40, so it can't be that. So our answer is going to be C. For number 14, I doubt that you'll have a question like this because this type of question was written before Desmos, but hey, if they're going to give it to us, we're going to try it, right? It says, select the number that represents the region of the graph you want to select. Zach began graphing the system of inequalities shown. So a system just means two or more. So we have two or more inequalities here. To complete the graph, Zach must shade the region which represents the solution set to the system of inequalities. What region of the graph needs to be shaded? I know this is all like blah, 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 blah. What is this talking about? Easy peasy again, we're going to let Desmos do it. So for Desmos, you're going to type both of these equations in, and you're going to look at the graph and see which part is shaded. So let us take a look. Here's the previous question. All right, we're going to clear that out. So y is greater than or equal to 2/3 x plus 1. All right, and then we're going to put the second equation underneath. So they're going to actually layer on top of each other. 5x plus 6y is less than or equal to -30. And if you zoom out, the solution sets now here, so our graph has actually 3 shaded areas, right? Well, one of them is red, one solution was red, and one solution was blue. The solution set is where they overlap. So it's going to be this dark blue area to the left. So if we go back, it would be right here, section 2. All right, section 2 would be the solution set. Remember, this section was red, this section was light blue. The solution set is where they overlap, and they overlap right here. There is on our Canvas page on the SOL review info, there is going to be a page about inequalities that will explain this, and Ms. Oliver and I are going to also teach it to you in class a little bit. Question 15. Directions. Drag the answers to the correct boxes. Each answer may be used more than one time. Using the inequalities shown, create a system of 2 inequalities that could be represented by this graph. So they give us the inequalities. Well, they give us the numbers and letters, and we have to figure out which symbols to put in to make it look like this, okay? So what I would do is first, I would type these in Desmos with equal signs. So that's what I'm going to do first. I'm going to go over to Desmos. Let me find my inequalities. Here we go. I'm going to take these ones out. You can hear my cat crying. And I'm going to start it with an equal sign. So y equals, this is the first one, -1/2 x plus 2. And then I'm going to put in the second one, 2x plus 5 equals y. Okay, so let me go back to the picture here. I want the one going up and down to be dotted. And I remember that the shading is the overlap. So if I'm shaded up here, there's going to be some shading in this direction, and there's also going to be some shading in this direction, right? This is going to be the overlap area that shows it all. So I want it to look like this, and I want this line to be dotted. So let me go back to, that was the blue line. So I got to come to the blue line and figure out how to make it dotted and how to make it shaded in the right area. So I know it's either going to be less than or greater than. All right, if I make it less than, it shades over here to the left. And I don't want it shaded to the left. I want it shaded to the right. So I'm going to go back and I'm just going to change that to greater than. Okay. For the green line, I want that one to be solid. So it's going to be less than or equal to or greater than or equal to. So let me try less than or equal to. Okay, that shades on the bottom. Let me zoom this away so you can see a little bit better. Let me move that. There we go. Okay, this is shaded on the bottom, but I want mine shaded up on the top. So that means I need to switch that to greater than or equal to. Let's make that here. All right. So I have this area right here where the purple and the green overlap. That is the solution set, and that matches what I have right here. So my first equation needs to have greater than or equal to. So I would put greater than or equal to right here. And my second equation needs to have greater than. So I would come here and I would put greater than. You would have to drag these in. But this is, again, this is a way that you can use Desmos and just trial and error to make the picture match what you have. Okay. Here is question 16. We're going to talk about functions now. Let f of x, remember that for a function, the way that you say this is f of x. Let f of x equal x and g of x equal 6x minus 1. Complete the statements to compare the graph of g of x to the graph of f of x. Well, if I'm going to compare the graphs, I need to see them. So I'm going to go to Desmos right now, and I'm going to type these two graphs in, and then I can look and see what they're asking me to compare. So the first one is f of x equals x. Okay, it looks like that's just a line. Second one, g of x equals, what did it say? 6x minus 1. Okay, so that's the red line. So now I know what they look like. Let me see what they're asking me to do. All right. So they're saying the graph of g of x, that was the red one, is it shifted? And on the screen, you can choose up or down. Is it shifted up or down from f of x? Well, let's see. Let me zoom way in. Does it cross at 0? No, it doesn't cross at 0. Okay, the black one crosses at 0, but the red one, look at where the intersection is. 0, and then this one is down here. Look at the y-intercept. So this one was up here, this one is down here, so it shifted down. So for this, we're going to say that it's shifted down from f of x. And then they want to know if the graph of g of x is steeper or less steep. Remember, this is, when we talk about steepness, we're talking about slope, right? Steeper is going to be more uphill, less steep is going to be more flat. So let's look at our graph. Here is, think about your skier. This is the original graph. Skier's going up. Here's this one. Holy moly, that is way steeper. So we are going to choose that it is steeper. All right. Anytime they talk about a graph, man, just type it in and then you can start looking at what they want you to see. Look, here's number 17. It says directions, select the correct answers. Let f of x equal x. The graph of g of x is shown. So this graph is g of x. F of x equals x is a graph that goes through 0, and it goes exactly diagonally through these dots like this. f of x equals x has a slope of 1. And so it looks like that. Let me see if I can draw a line on here. And you would be able to do this on your screen. You'd be able to use the dot tool and the line tool, okay? So there is f of x. Okay, the slope of g of x is twice, 1/2, 2 less than, or 2 more than f of x. Well, f of x, you could replace f of x with y, and the other one would be whatever this one is. If it says y equals x, we know the slope is 1. All right, so for the slope of g of x, we're going to need to find it. So remember to find 2 points that are in the crisscross. Remember, it has to go through the little cross on the graph. Up and over, up 1, over 2, so our slope is 1/2. So the slope of g of x is 1/2 the slope of f of x. The y-intercept of g of x is right here, which is 2. Is it twice, 1/2, 2 less than, or 2 more than the y-intercept of f of x? Well, the y-intercept of f of x is 0. So it would be 2 more than, because it's 2. Okay, there you go. Number 18 says, let's see, plot each point on the coordinate plane. A line will extend through the 2 points. Let f of x equals x. Remember, whenever you go through 0 and you have an exact 45-degree diagonal, this is f of x equals x. The graph of g of x is shifted up 2 units. That means on the y-axis, you go up 2 from wherever the other one is. So that's going to be a point. And it's 3 times as steep. So remember, the slope of this line is 1, right? Up 1 over 1, up 1 over 1, up 1 over 1. So the slope of this line is 1. If this slope is 3 times that, then our slope would have to be 3. That means up 3 over 1, up 3 over 1. And when you as soon as you put a second dot on there, it's going to make the line for you. And that's what they want you to do, is they want you to put 2 dots on and make the line. So this is what your graph should look like, something like this. Question number 19. A function f is described. So f of x equals x minus 2 squared plus 3. The domain of f is all the real numbers greater than 0. And they want to know the range is all real numbers greater than or equal to what number. So basically, remember that domain is all the x's and range is the y's. So when you see f of x equals x minus 2 squared plus 3, you can take this out and put y. And then what you can do is, it says the domain is all real numbers greater than 0, so not 0, but greater than. I would try 3 or 4 numbers in Desmos and see what my answers turn out to be. So I'm going to go to Desmos and I'm going to type this. Actually, I'm just going to type this part and see what I get. So let me get rid of that. Let me get rid of that. So let's see. X minus 2. Whoops, why do I have a 9 there? That was a typo. Okay, x minus 2 squared. So I got to use the squared. All right, where is it on my paper? Plus 3. Okay, so what if I put in 1? All right, I get 4. I'm going to write that down. If I put in 1, I get 4. I'm going to try these numbers. Remember, this is x, this is y, right? So let's go back to Desmos and put in 2. If I put in 2, I get 3. Let me try 3. If I put in 3, I get 4 again. If I put in 4, I get 7. And if I put in 5, I get 12. Okay, so this is giving me a trend here. I think if I keep going higher, I'm going to get higher numbers. They want to know these numbers are greater than or equal to what? Well, none of them are 2, and it says or equal to, so that can't be it. The lowest number is 3. These numbers are all greater than or equal to 3. It can't be 5 because I've got 4 and 3 here. It can't be 7 because I've got 4 and 3. So the answer would have to be B. These are all greater than or equal to 3. So the domain and range in this case is just trial and error, putting in your own domain numbers and seeing what range numbers come out to see what you would have. All right, for number 20, directions, select all the correct answers. Identify each function that has exactly 1 0. When we talk about zeros, again, if you look on the quadratic equations document on the SOL review page, remember a 0 is where the line, or where the, let's say where the graph crosses the x-axis. So basically what we have to do is just type in all of these and see which ones cross the x-axis. So it's going to be a little bit tedious, but that's okay. All right, so the first one, and by the way, when you type these, you don't have to type the f of x, g of x, like you don't have to type this part. You just have to type this part without the equal sign, okay? That will make it a little bit faster for you. So the first one is 9x squared minus 4. 9x squared minus 4. And they wanted to know which ones had only 1 0. So it means that they only cross the x-axis in one place. Well, this graph crosses it twice, here and here. So that one is no good. Let's try the second one. I know it's not that. 9 times x minus 8. 9 times x minus 8. Where even is that graph? Oh, there it is. Okay, might have to zoom out. And it looks like it's a straight line, and sure enough, it crosses the x-axis only in one spot. So that one is good. So we're going to say, yep. Okay. X squared plus 4x plus 8. X squared plus 4x plus 8. All right, well, this one doesn't cross the x-axis at all. It crosses the y-axis, but that's not what 0 means. 0 means where does it cross the x-axis? So this one has no zeros, so that's definitely no good. Okay. X squared minus 8x plus 16. Let's do this. Minus 8x plus 16. All right, so this one looks like it crosses the x-axis in exactly one spot. It comes down, turns around, and goes back up. So that is a good answer. And let's check the last one. Negative 2 times x plus 4 times x plus 1. Negative 2 times x plus 4 times x plus 1. There we go. No good, because we're crossing the x-axis in 2 places. And they want to know which one crosses once. So you would choose these 2 answers. So the whole key to this type of question is knowing what do they mean when they say 0. All right, so a 0 is where the graph crosses the x-axis, not the y-axis, the x-axis. Here's number 21. This is another sort of multiple option. Identify each function that has an x-intercept of 3. So that means when you graph this on the x-axis, it has to go through the number 3. So again, we just let Desmos do this for us. We're going to not type this part. Forget about the, h of x and 0 of x and all that. Just type this part, and we'll see which ones cross the axis at 3. So let's see, the first one is negative 4x plus 15. Remember that in order to get all this in the numerator, you've got to put it in parentheses like that, over 5. All right, and then what you can do is just click on this dot and see if it's 3 or not. It'll tell you exactly what the number is. So that one is 3, that one is a yes. Oh, wait a minute. X-intercept. Ooh, did you guys catch that when I just made that mistake? Wah, wah. X-intercept. 1, 2, 3. We're looking here, not the y-axis. Ooh, see, tricky. Let's look at that one. That one crosses at 3.75. No good. All right, 3 minus 1/2 x squared. Let's try this. 3 minus 1/2 x squared. All right, does that cross at 3? No, it does not. It crosses at 2.449. So that one is no good. How about 5/3 x minus 5? All right, 5/3 x minus 5. Let's see what that is. Aha, we have a 3. All right, so that one is good. We would pick that one. X plus 3 times x minus 5. X plus 3, x minus 5. Whoa. I thought I erased that. I guess I didn't. There we go. Okay, is this crossing at 3? No, that's crossing at 5. So that one's no good. How about 3x squared minus 11x plus 6? There we go. All right, 3x squared minus 11x plus 6. And we're going to check it and see. Yep, crosses at 3. So that is another one. So we would pick these two answers. Oh, you guys, be very careful that you don't get fooled like I do. We've been talking about equations so much. We've been talking about the y-intercept, but this one is asking about the x-intercept, and I almost got majorly fooled. So be very, very careful. For question number 2, which table of values best represents the rule shown? The square of the sum of x and 5 is equal to y. So the trick is being able to put this into numbers. This is the very first thing that we did at the beginning of the year. The square of the sum means that I need to add first and then square. So the sum of x and 5, and if I want to square the sum, I have to put the whole thing in parentheses and square it like this, is equal to y. All right, so then all we have to do is put in our x number, 3 and 4, and see what y number comes out. So again, you can do this by hand or put it in Desmos. We're going to put in x plus 5 squared. Let's type that in. So x plus 5. And for this, I don't really care what the graph looks like. I just want the numbers, right? So if I put in 3, I get 64. So let's look at our answers. 328, nope. 314, nope. 364, yep. 334, nope. Looks like this is the answer, but you know what? I'm going to test 4 just to make sure. So I should get 81. Let's go back and change that to a 4. Haha, there we go, 81. So this is the correct answer. Number 23 says to plot each point on the grid, a function is represented by this rule. 1 more than 1/4 the square of a number x is y. Okay, so 1 more than means that you need to add 1 to the end. Remember, more than and less than means to take that number and put it after. 1/4 the square of a number x. So 1/4 the square of x plus 1 is y. There we go. Then it says plot 3 points on the grid that are represented by this rule. Each point must have coordinates that are integers. So we don't want any decimals. What we're going to do is we're going to type this into Desmos, and then we're going to go up the line until we find 3 points that are integers that we can plot on this line. And I'll show you how to do that. 1/4 x squared. Let's get this typed in. 1/4 x squared. Let me find it. Plus 1. Okay. So here's one right here. This is called the vertex of the parabola. The vertex is 0, 1. So you would go to your graph that they give you and you would put a dot on 0, 1. They would give you the tools to do that. Then we have to find 2 more points to put on there because it says to plot 3. So let's look over here. And what we can do is we can slide. You can slide up until you find, you see where it hits and there's no decimal. So 2, 2 is also a good answer. So let's come back here. We'll go to 2, 2. And then we need to find one more where there's no decimals. So we can try going up to 3. And you gotta, all right, so 3 is no good because you see with 3, come on, with 3 we have 3.25. It's got to be no decimals. Let's try 4. I'm going to slide up and I'm going to finesse this until I get exactly on 4. Aha, there we go, 4, 5. So 4, 5 is also a good answer. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, there could be other points, right? You could go to the left if you wanted to. All right, you could go and you would find, for example, -2, +2. You would find -4, +5. They're mirror images of each other. Let's see, but this time one would be, oh boy, it's hard to get it exact. There we go, -4, +5. In this case, the x is negative, the y is positive, the x is positive. Like, it doesn't matter where you go. You can look up here and try to find one. Let's see, 8. No, 8's not going to work. I mean, you could just keep sliding. You could look anywhere. As long as it fits on your graph that they give you, right? We can only go up to, it looks like 10. So these 3 points are probably good options. All right, number 27 is the last question I think that you could answer easily. It says using the quadratic curve of best fit. Well, we don't know what that is because we didn't have time to teach it for you, but you can still answer this question. Which equation most closely represents the set of data? Again, I have a set of points here. I know that I can go to Desmos and I can type these points in and they'll show up on the graph. Then I know that I can type these equations in and they will also show up on the graph. They want to know which one is the closest. Which one of these is the closest to that? So I'm going to put the table in and then I'm going to put these 4 equations in and see which one matches it the best. So let's come over here. So remember, to make a table, you hit plus and you hit table. And we're going to put in our data. So the first point was -8, 80.4. The second point is -7, 57.8. The third one is -6, 38.6. The fourth one is -5, and I know this is kind of tedious, but this is what you got to do to answer the question, and you just got to be very careful when you're typing. 18.8. Always double check to make sure you typed what you think you typed. 551.8, and then 798.4. Okay. Now, I have a whole bunch of points here, but right now I can only see 2 dots. So I need to zoom way out until I can see all my dots. Actually, I'm going to, as far as I have to, but as close as I can. I want to see these dots as largely as possible. Okay, now I'm going to keep the table here, and I'm going to go to the next row and type in the first equation. And remember, you don't have to type the y equals part if you don't want to. You can just type starting with the x squared, okay? So the first one is x squared plus 2x minus 5. So here we go. X squared plus 2x minus 5. All right, well, if I look, this doesn't really represent the data. I mean, we want the one that's close. I mean, I guess it's close, but when you zoom in, you can see that these points are really far away from the line. But I guess each point is kind of the same distance away, so I don't really like this one, but I guess I could see how maybe it's an answer, so let's just sort of put like maybe next to this one. Maybe. All right, let's try the second one. X squared minus 3x plus 5.2. I'm going to take that out, but I'm going to leave the points. X squared minus 3x plus 5.2. All right, now this one is way off. we've got the line is close to a couple dots, but then look at this. We got, there's no way. That one is a hot mess. So we're going to say no. Definitely not for that one. All right, let's try the third one. 1.7x squared minus 3x plus 5. 1.7x squared minus 3x plus 5. That's not really much better, is it? It looks like this parabola is shifted over to the right. If it was just over to the left a little bit. I mean, yeah, no, I don't like that one either. Gosh, I really hope the last one works. And it is 1.7x squared plus 2.9x minus 5.2. So 1.7 x squared, let's see, plus 2.9x minus 5.2. Oh my goodness, look at that, guys. We have a winner. Ding, ding, ding. This parabola perfectly matches these points. So our answer is going to be the last one. There we go. And see, for this, we didn't need to know what this curve of best fit is. There's a way to actually type an equation in Desmos that will tell you what the X and Y numbers should be. But we didn't need that, right? That's something that you would have had to memorize, and I would have had to teach it to you, and you know, you don't need that. Just by typing stuff in, we were able to do trial and error and find the one that works, and the answer was D. Okay. Number 28 is similar to this, but I will tell you that when you put these numbers in the table, because these numbers are so big, I mean, 59,900. When you put this in Desmos, it just looks like a line that's like right here. And you have to zoom out to like where it's, you know, thousands. So it's really impossible to get close enough to be able to see what the answer ought to be. I would just say, look at how this is going up. You know, this from 10 to 17,000 goes up 7,000. From 17,000 to 23,900 goes up 6,900. From 23,000 to 31 goes up another about 7,000. From 31 to 43, now that one makes a big jump. That's more like about 12,000. So from 43 to 59, you're going up 16,000. So you go up 7, and then you go up to 12, and you go up to 16. I'm going to say that this is probably at least plus 20,000. So if you take 59 and add 20,000 to that, you're going to get 79,000, which means it could be any of these three. And you just take your best shot at which one you think it is. When they're not all the same, that means you have another shape like this. And the numbers at the bottom are closer, like they're not as far apart, but then the further up you go, the farther apart they get. So I don't know. I think the correct answer to this one was the 91, but at least you would know that this one was too small. This one might be too exact, and you should go, you know, try for the two big ones. This is one that, again, you could sort of just, you could reason your way to at least have a 50-50 shot at it. Okay. And guys, that is all the questions that were on the TestNav. I've gone through and hopefully showed you how you can use Desmos for a lot of these. Just ask yourself, anytime you see coordinates, you can graph it. Anytime you see an equation, you can graph it. And for any kind of math, you can use Desmos for it. So there's a lot of things that Desmos will do that you can figure out the answer, even if you don't really understand what they're asking you, my cat, what they're asking you, or if you don't really understand all of the words in the question, a lot of times you can match it just by using Desmos. So there you go. If you have any questions, feel free to email me or come to office hours this week.